Students, this is your first recording that's supposed to go into your reference booklet. We're going to be going over some of the basic algebra review here. So one of the most basic skills you need to be comfortable with this class is solving for x. Your goal is to get x all by itself and then get the numbers on the other side. So here we have a fraction. Now your first instinct might be to do this, but then you're going to end up having multiple fractions. So if you ever have a fraction on the outside here, before you distribute a fraction, the easier way to do this is to actually just cancel it out completely. So we're going to multiply everything. If you want to cancel that, we have to multiply everything by its reciprocal, which is 3 over 1. So we're going to multiply that by 3 over 1. We don't have to do the parentheses because we're getting rid of it by canceling this. Then we have to do 3 over 1 here and 3 over 1 here. So your next line should read 3 times 1/3 turns into 1. So I have 1 parentheses 4x plus 4 equals 6x minus 36. Now if I distribute the 1, you know that it's just 1. So I have 4x plus 4 equals 6x minus 36. So I want to get my x's on one side, so I'm going to minus 4x. So I end up with 4 equals 2x minus 36. So I'm going to do plus 36. Plus 36. 36 plus 4 is 40, so I have 40 equals 2x. Divide both sides by 2. End up with x equals 20. Another thing we need to be able to do is add or subtract radicals. So the first thing you want to deal with when you have radicals is just to see if any of them can be broken down, if there's any dates. So we take a look here real quick and see if any of these can be broken down into dates. And this is 1 and 3, 1 and 2, 1 and 3, 1 and 2, and then 1 and 5. And you see those are all prime. So we can't break them down or simplify. So now your goal is to simply collect like terms. So as we collect like terms, we're going to collect all the root 3's. And then we have some root 2's. And then the root 5 is by itself. So 3 minus 6 is going to be negative 3 root 3. And then this was 5 plus 7 is going to be plus 12 root 2 minus 9 root 5, and you're done because you can't simplify anymore. Now when you multiply and simplify radicals, the trick here is you just want to multiply outies and innies. So taking a look here, we're going to multiply outies and innies. So when you multiply the outie, we end up with 3 times 9. We're going to multiply the innie, square root of 3 times 6. Now we're going to break down that 3 times 6 a little bit. 3 times 9 is 27. I want to see if there's any dates here. This is still 3, and then we have 3 times 2 for the 6. There is a date, so we can pull out this 3 here. It comes out as a single 3, so I'm going to do 3 times 27. Do that longhand. Try not to use a calculator if you can help it. 3 times 7 is 21. Carry the 2. 3 times 2 is 6, plus 2 more, so it's 81. So I end up with 81 square root of 2. Now here in simplifying for x, our goal again is to get x by itself. So the first thing we're going to do is we're going to get rid of the 12. So we minus 12 both sides. I end up with x squared equals 24. Now, the opposite of squaring is square rooting, not dividing by 2. So I have x equals square root of 24. But you can simplify this a little bit. So we're going to simplify it. That's going to be 2 and 12, 2 and 6, 2 and 3. So we look for our dates, and we have a pair of 2's that can come out. So I have 2 square root of 6 is your final answer there. We're going to do a little bit more with radicals here. Root 3 times root 3. See, we just multiply the radicals on the inside. Root 3 times root 3 technically is a square root of 9. However, square root of 9 is perfect, so root 3 times root 3 ends up just being 3. Really important pattern you need to see here. Any radical times itself is just the number on the outside. So root 3 times root 3 is just 3. So let's ask ourselves this. What times root 5 is 5? Remember, I just said any radical times itself is just the number on the inside. So look at the pattern. If we want just 5 out here, we need a root 5 times root 5. So what goes in this blank spot is root 5. Here's how you test it. Root 5 times root 5 is root 25, which is perfect, which becomes 5. Let's try this again. Okay, now we have a 20 here, so where'd our 5 go? Well, let's remember what we know so far. Any radical times itself is just the number on the outside. So, for example, root 2 times root 2 is 2. Root 3 times root 3 is 3. Root 5 times root 5 is 5. Any radical times itself is just the number on the inside. So if I want to get rid of this root 5, the first thing I have to do to put in this box is another root 5. But root 5 times root 5 only gives us 5. So next thing you need to do is ask yourself, what times 5 is 20? What times 5 is 20? So the answer is 4 root 5. So what goes in this box is 4 root 5. So 4 root 5 times root 5 equals 4 times 5, which is 20. There's your check.